All right, this is geometry lesson 4 on page 151. All right, there's this image on page 151. The title of the lesson is Congruence Proofs. So these two cowboys, they start out at this point A, and the information is giving that AD is perpendicular to AC. So we know if that information is given, two lines are perpendicular. If I tell you AD is perpendicular to AC, can I know something from that?
They're both right angles.
Okay, so if it is given that AD is perpendicular to AC, then I can know, where's there a right angle? Correct. Angle A is a right angle. Why? What would be my reason why?
Because two perpendicular lines form right angles.
That's correct. Perpendicular lines form right angles. Okay, what can I know from this? Angle A is a right angle. Can I know the measure of the angle?
Angle A equals 90 degrees.
Yes, angle A is 90 degrees. Why?
Because all
Because
right angles equal 90 degrees.
All right angles equal 90 degrees. Okay, so you see from that one given statement, there's some information I know. All right, now, so the cowboys go from A, which is perpendicular to the drive-in, I believe, and they go to B, which is the midpoint of AC. So, based on that given statement, B is the midpoint of AC. What can I know from that statement?
Side BC equals AB.
All right, that's given. Why?
Because the midpoint splits it into two sides.
That's correct. A midpoint divides the segment into two equal parts. You see how we're taking the given statements and deriving more information from it? That's how you work a proof. All right, so both the cowboys stop at the midpoint. One cowboy goes to EB, but the other cowboy goes to C. And when he's at C, they realize that CE is also perpendicular to AC. So they also realize that CE is also perpendicular to CA. All right, so that is given. So what can I know from that? Perpendicular lines form
Right angles.
right angles. So what angle is a right angle?
C.
Angle C is a right angle. For the same reason, perpendicular lines form right angles. Then I can know angle C is what?
90 degrees.
Because all right angles are equal. All right. Can I know that one angle in the triangle on the left is congruent to one angle in the triangle on the right? Which one, Sam?
Angle CBE is congruent to ABD.
So angle CBE is congruent to, what did you say? ABD. Why?
They're vertical angles.
So all vertical angles are equal. Okay, so here's what we've said so far. We said these two angles are equal and these two sides are equal. Do I need another side or another angle? Equal. I do. You know what have I not said yet? I have not yet said angle C equals angle A. Do you see that? I have to say that. So why can I say that angle C is congruent to angle A?
Substitution.
Okay, I could say I would actually take that. Is there another thing, another statement that I would take?
They're both equal to 90.
And all right angles are equal. So I would either take substitution or all right angles are equal. All right, so this is really one of the points I wanted to make. We said they're both right angles. We said they're both 90 degrees, but we never said they're equal to one another. In order to complete a proof by ASA, or side angle side, you have to say those three parts are equal. All right, now I can say that the triangles are congruent, right? And how would I write that? Triangle what? Start with the one on the left. What letter order?
CEB
CEB
is congruent
to
AD.
ADB. ADB. And why? What would be the reason? ASA. All right, so you would need these other statements, but these four statements are key. These three statements are key for writing that statement. Okay, if I know that two triangles are congruent, can I know that every corresponding part is congruent? Yes. So what are the parts are congruent?
Angle D and E.
Angle D and E are congruent. That is correct. What else?
Side EB and side DB.
Correct. EB and DB are congruent. And I can know one more side. DA and EC. So once I have a congruent statement, I can write any of those three statements. I can say angle E is congruent to angle D. I can write, what did we say? CE is congruent to AD. And I can write EB is congruent to DB. And my reason for that is always going to be this. I can only say, here's what's important. I can only say this once I've proven that the triangles are congruent. If I don't know that the triangles are congruent, then I can't say that those parts are equal. But once I prove congruence, I can say every other part is equal. And here's going to be your reason. Corresponding parts of congruent triangles are equal or congruent. That's always going to be your reason. Once I have congruence, I can say any other part is equal because corresponding parts of congruent triangles are equal. That's the statement on page 152. Corresponding parts of congruent triangles are equal. All right, does that make sense? So now we're going to work a proof where I'm not going to ask you to prove that the triangles are congruent. I'm going to ask you to prove that one of the parts from each triangle is congruent. But to do that, I first have to prove that the triangles are congruent. All right? So let's work this one. All right, here's the image. Here's the given. And this is what we're going to prove. All right, so what's going to be my first statement? What do I always write first? Y'all are getting good at this. The givens. Okay, everybody's going to write the givens, right?
Mm-hmm.
I really am excited and hopeful that that is really going to be the case. All right, so I'm going to write the first given. OM bisects angle LMN, and it is given. All right, is there anything I can know from OM bisecting angle LMN?
Angle L and O and NMO are congruent.
Yes. So if this bisects this angle, then those two angles are equal. And why? What would be my reason?
Because when an angle is bisected, it creates two equal angles.
Yeah, when an angle is bisected, the angle is divided into two equal angles. Exactly what you just said. A little close. Right? All right, so what did I say? Mark it, right? We have an angle, and I've marked it. Okay. I'm going to write my next given statement. Angle LOM is congruent to NOM. I can write that because it is given. So LOM is congruent to NOM. All right. So I have two angles. So if I have two angles, what am I looking for?
A side.
A side. Luke, do you see a side that I can prove? Mm-hmm. That's the side I need to prove. Okay, so what would I write?
Side
OM
equal to
equals. What am I going to write, ladies and gentlemen? OM. Is OM in both triangles?
Yes.
It is. Why can I write that?
It's reflexive.
It's reflexive. And I mark it, and that's a side. Do I have congruence? I have congruence. So I'm going to write triangle. Let's do LOM. LOM is congruent to, how am I going to write the other side? I did that kind of backwards, actually. NOM. Why can I say that? ASA. Now can I say that these angles are equal? Yes, I can. So I can say angle L is congruent to angle N. Why can I write that? What's my reasoning?
Corresponding parts of congruent triangles are equal.
Corresponding parts of congruent triangles are equal. Always, right? Once I've proven congruence, corresponding parts, that's how I write it. Corresponding parts of congruent triangles are equal. Got it? All right, let's do one more. I'm gonna let you work this one for homework, actually. So this is gonna be part of your homework. See if you can do it. All right, that's the image. So y'all all need to write this down. Here's the given statement, and I actually want you to hand it in to me. I wanna see how you're doing. And that way I can gauge before the test. So do it on a separate sheet of paper. Here's the given statements.